All right, welcome everybody. It's 7 o'clock, so we'll go ahead and get started. What I'll cover today is just a few of the things that you were supposed to learn this week, specifically variables, statements, operators, expressions, strings, how to get user input, and how to do comments. So I'll briefly go down code examples for each one of those. And then at the end, I'll go ahead and take any kind of questions or comments you may have about the assignment this week or anything in the class up to this point. All right, so I use Ubuntu as my operating system. The same things that I do here will work on Windows if you're using Windows. So the first thing I'll do is make a Python file. Make a blank file. I'm just going to call it program.py. So I have a file here where I'll put all my Python code. Now you can use any text editor you want. I know the class has you install, I think, Python idle, and that's fine if you want to use that. That's a good text editor. I use Visual Studio Code to do my text editing in whenever I do programming. So that's what I will use. So I have this program.python file here in Visual Studio Code. And then whenever I'm ready to run the program, I'll use my terminal to run it. So one of the first things you do in any programming language is you learn how to print something out to the screen. And in Python, it's as simple as the command print. Inside here, you put the text you want to print out to the screen. So we'll just put hello world. I'll save that file. Now I'll come over here to my terminal and run Python 3, my program.py file. There we go. Hello world. Easy as that. That's how we can print something to the screen. We can also print any text you want in here. Any text you want. Save it. We can run our file again. And of course, that's exactly what it prints out to the screen, any text you want. And one of the things you needed to know this week is variables. A variable is just, well, I guess a variable in your program that can contain any value. For example, I want to have a variable and I'll just name it var. And I can set what I want it to be equal to. Now this variable can be a number, like 12. It can be a string, like this is some text. Anything like that. And what variables are useful for is instead of having print the specific text, I can say print this variable called var. Now whenever I save this and I run the program now, it prints out this is some text because this variable, which I've named var, is equal to this string. And I'm saying print that variable, so it'll print whatever that variable contains. This is some text. Now this can be a number. Let's say just put 12. Save it. Run it. And it prints out 12. So it can be a decimal number. Save it. Whoops, I didn't have my number key on. There we go. To save it. This variable is now this floating point number, and we will print that variable as well. And there it is. That's what it prints out. Now, what else are variables good for? Let's say we want to do some kind of computation, right? I can have variable 1 is equal to the number 12. Let's say I can have variable 2 equal to the number 15, right? And we want to do some kind of math computation. Let's say we want to add them together. Do variable 1 plus variable 2, and we will print the result. So I have a variable named var1 equal to the value 12. I have a variable named var2 equal to the value 15. I'm going to have a result which is equal to those two numbers added together, and then I want to print out the result. So let's save it. Let's run it. And the answer is 27. Let's say same thing works for multiplication. Save it, run it. That's it in multiplication. Subtraction, same thing. Any kind of mathematical operation you want to do. One of the trickier ones that can sometimes be hard to grasp is an exponent. When you have, say, 2 raised to the 3rd power. In Python, that's represented with 2 consecutive stars. If it's just 1 star, it's multiplication. If it's 2 consecutive stars, then we're talking about an exponent. So this right here will take 12 raised to the power of 15. Probably going to be a big number. Save it and run it, and that's the answer. So we can use these variables to store values, and we can use these operators to do some kind of mathematical operation on them. What we have to be careful with is, let's say this was a string 15. There is a difference between a string that is 12 and an integer or a value that is 12. So string 12 is not the same thing as the value 12. So when we do this right here, we're going to take the string 12 and add it to the string of 15. And in Python, when you add strings together, it just concatenates the result. So we have 12, 15, which is just the strings put side by side. Now we can try to do these other operators, and this doesn't make sense. It doesn't make sense to have the string 12 minus the string 15, and Python will complain about it. See, it gives us some kind of error that's saying you can't subtract strings from each other, and that makes sense. Same thing if we try to multiply strings together. We get an error because you can't multiply strings. You can multiply values, but not strings. And that'll be the case if one of them is a value and one of them is a string. We still can't do those operations. Well, that works for a different Python reason. Don't worry about that. Basically, if you take the variable times a string, it just repeats that string that many times. So you can count those up if you want to. But it doesn't do what you're expecting or what you think it should do. So in general, in Python, when you're doing operations, you want to make sure they're actually number values, or if they're strings, that you're only adding them together, because that'll make sense. And why would you want to add strings together? Maybe I want to have a variable called first name and a variable called last name. So what I can do, I can run this, and let's say I have this stored in a database or something like that, and now I want to display to the user their whole name. So we can do that by just adding the variables together. Oops. The reason why that gave me that error is because I renamed these first name and last name. So right now, variable 1 no longer exists. Variable 2 no longer exists. Since I renamed them here, I need to rename them in my computation. Save that and run it. There we go, Dan Steffi. Now we can put a space in there too. Space it out. There we go, Dan space Steffi. So that's what our variables are, and that's what our operators are. Operators are your standard math functions like plus, minus, subtract, divide, exponent, and those kind of things. And we already talked a little bit about strings. What the difference between a string and a value is. When I had up here the difference between that 12 and the number 12, two totally different things. One, the string is just text. It doesn't actually represent the numerical value 12. This represents the numerical value of 12. So that's the difference between a string and a value. So let's talk about user input. So let's say we want, let's erase all this. Let's say we want the user to put in their name. You're asking them, what is your first and last name? Okay. In Python, we can have that with a variable. I'll have it called first name equals input And inside here, we can put whatever we want the prompt to be. Enter first name. Okay. Let's just save it and let's just run that right there. So we execute this. It's going to prompt you to enter your first name, which is what we have right here. And I'm going to type it in. And that's all the program does right now. But what ends up happening is whatever I type in at the keyboard right here is going to be stored in this variable. So if I do a print first name, what's going to happen is it's going to ask me to enter my first name. Whatever I type in will be stored in first name, and then I'm just going to print it back out. Let's run that. Type in Dan, and it printed back out Dan. Let's do first and last name. Last name, enter last name. We'll print out the first name, a space, and the last name. So it's kind of like what we did in that previous example. It's just instead of hard coding in Dan and hard coding in Steffi, I'm asking the user to type it in. Save it. Let's run it. Enter first name, Dan. Enter last name, Steffi. And there it prints back out, Dan Steffi. Let me increase the font on this in case, to make it easier to see. Now this should be good enough for the font. So that's how we get user input. Now you got to think, when we talked about what's the difference between a string and a value, okay? So let's say we have a first number, enter first number. Let's do a second or a last number. No, call it second number, enter second number. All right. So let's say we want to do some kind of math operation on this. We're asking the user to put in a first number and a second number. Let's say we want to add them together. So we do result is first number plus second number, and then we'll print the result. Does anybody know what the problem with this is? Well, let's run it, and hopefully you will see what the problem is. So let's run it. Enter the first number. Let's put in 12. Enter the second number. Let's put in 16. And it should add them together and print out the result. Do it. But look, 12, 16, that is not 12 plus 16 added as number values. It is 12 and 16 as strings kind of concatenated together. And the reason is this input function here in Python, it always gives you a string in return. What I mean by that, in Python, if you want to see what the type of a variable is, you can print type first number. Let's comment out these so they don't run. Those are, when you put a hashtag in front, it means to comment it out. It means this code doesn't actually run. So when I do this, I'm going to print out the type of the first number, and let's print out the type of the second number. Second number. Save it. Let's run that. Enter the first number. Let's say I put in 14. Enter the second number. Let's say I just messed up and put in ASDF. Enter. The first number is a string. Even though I typed in 14, it's still a string. And of course, the second number is also a string. And the reason being is that whatever you type in at the keyboard, whenever you talk about input, it is always treated as a string. Well, how can we change that? Because we really do want to add them together. We'll leave those in there. We really do want to add them together as normal numbers, but right now they're strings. What we can do is we can convert a string to a number value. We can do that with the first number can equal int of the first number. And we'll do the same thing with the second number. second number equals int second number. And what that's doing, it is taking this string, converting it to an integer, and assigning it back to the variable first number. And the same thing with the second number. So let's run this and see if it gives us what we want. So we'll get first and second number as input from the user. We'll convert them from their string to an integer. We'll still print out the type, just see what type they are, and then we'll print out the result. So let's run that. Enter first number, 12, enter second number, 14. Sure enough, at this point where it does the print, it has been converted to an integer, it's been converted to an integer, and the result is correct. The result is 26, as it should be. What you have to be careful of is when you have this first number, you're trying to convert this string to an integer. Well, what if you don't type in an integer? What if I type in a decimal number? It gives me an error. And if you look, the error can kind of tell you where it's at. It's saying the error is on line 4. So if you look here, this is line 4. Invalid literal for int with base 10. But what it's saying is you try to convert 3.14 to an integer, and you can't do that because 3.14 is a float. It is not an integer. So we could change this to say float. And now that should work because 3.14 is a float. Let's run that again. 3.14. The second number is 5. And that ends up working out right because when we do this print type of the first number, it tells us it's a float, which is correct. And the second number is still an integer because what we typed in is 5, and we still convert the second number to an integer. And now for the result, we can add a float to an integer because they're both still values. One is just whole numbers, and that's what an integer is. An integer just means it is a whole number only. It can be positive or negative numbers, but it's only a whole number. And a float means it can be a decimal number. All right, so we print out the result. But it still holds true, even if we convert to a float, we still can't give it text. If we type in QWERTY, it tells us, the problem is on line 4, could not convert string to a float. So it was trying to convert, right here, it was trying to convert QWERTY to a floating point number, and you can't do that because obviously that is not a floating point number. It's just letters, right? See, what else? Actually, that actually covers everything that you were needing to do, needing to learn for this week. What I'll talk about now real fast is what you have for your assignment. Assignment 1, that'll be due Tuesday of next week. So I'll do like a semi-example. I'm not going to do exactly what the assignment says to do because I'm not going to give away the answer. But I'll do something somewhat similar. So for your assignment, you basically have the user type in the number of hours somebody worked and the amount of their weekly sales, right? Let's do something a little bit similar. Let's say we run a store and we sell apples, okay? So let's say num apples sold, and we'll ask the user to input how many apples sold. All right, so we'll ask the user to type in how many apples they sold. Now, as I said, this input is a string. We need to convert it to an integer. Num apples sold equals integer over num apples sold. That's just converting this string to an integer. I could have chosen a float, but it doesn't make sense to sell 3.1 apples. No, it makes sense to sell a whole number of apples. Okay. Then we'll ask, well, how much did each apple sell for, right? So amount per apple equals, well, again, ask the user, how much per apple? And that's just how much did each apple cost? Maybe each apple cost $1.30, Again, since we're using input, it returns a string, but we need to convert that to a number, right? In this case, it makes sense for it to be a floating point number because not everything costs, exact amount of dollars. So, maybe an apple costs $3, but maybe an apple costs $3.15, right? So we'll allow the user to type in how much each apple costed, and then that'll be a floating point number for dollars and cents. And now we want to figure out, well, how much money did the person make from selling apples? So we'll get the result will equal the number of apples sold times the amount per apple, right? And then we'll print, you made result. Actually, let's put a dollar sign in there too, so we know. Yeah, let's leave it at that. So what will happen is, let's go from the top to the bottom. I'm going to ask the user to type in how many apples they sold. It'll be stored as a string in this variable. I'm converting that variable to an integer and then storing it in the same variable. I'm then asking the user to type in how much did each apple cost, how much per apple. I will store that in as a string in this variable. I will then convert that to a float and store the result there. So now it's a floating number. And to get the result, how much money he made, we'll take the number of apples they sold times the amount per apple, and that's how much money they made. Let's run this. How many apples sold? Let's say we sold 10 apples. Amount per apple, $3.14 per apple. We run it. Oh, did something wrong, obviously. Print result. We can string, not float to string. Oh, nah, that's actually good that came up because that's going to be another thing I covered. So, result, actually let's print it here. Print the type of the result. Just like we did earlier when we were printing out types, what type is a result? And let's comment this out because I know it's a problem. We'll save it. We'll run it, say 56 apples, I don't care. So when we get here, the type of result is a float, okay? What I tried to do here is I tried to take this string and add it to a float. And like I was talking about earlier towards the beginning of the video, or the beginning of the Zoom session, is you can't take a string and add it to an int. You can't take a string and add it to a float. So how do we print this out? Well, just like here, when we wanted to take this string and convert it to an integer, or this string and convert it to a float, we can take this float and convert it to a string. So let's put it up a little bit higher. So we'll take the result equals string of result. Comment that out for right now. Okay, so result is a float because it was a number. Actually, because right here, we did the type of and saw it was a float. Now we're going to take this float, convert it to a string, and store it there. So result should now be a string again. Let's run that. 12 apples for $12.01. Okay, so it did this print right here, and it said the result is now back to a string. And so we can add strings together. Take away that print. And so now we can take this string and add it to the result because I converted the result to a string. Let's save it. Let's run it. 10 apples at $3.14 per apple. And there you go. Don't worry about all the extra zeros and stuff like that. I could do some formatting where it only shows up to, there for dollars. I'm not going to go to that for this this early in the class. You'll learn that later. But there we go. So this is actually very similar to what you need to do for your first assignment. Is, I take in how many apples were sold, how much per apple, and I do some computations, and then I print it out to the screen. For your assignment, you have to ask the user how many hours they worked this week, how much in weekly sales did they do this week, and then you need to perform some computations on that, and then print out the result. And then you have some other things to do as far as making a Word document, and you can read the specific directions on what needs to go into the Word document. But this is very, very similar to what you need to be doing for your homework assignment for this week. And that is all I have to cover. That's all you need to know in Python up to this point in the class. So this assignment is due Tuesday night by 11:30 p.m. Eastern Standard Time. If you need more specific assistance between now and then, please feel free to email me. Email me is definitely the preferred method of communication because I get notifications whenever I receive an email, and I can generally respond to those faster. So I'll open it up now to any questions you may have. It can be specifically about what I did just now or anything going on in the class. If you don't have any specific questions, I guess you can go ahead and drop off. But I will take this video and get it uploaded and put a link in the class so you can go back and watch it if you need to. So the floor is open for any questions you may have.
Hi, this is Chris. I had a question about the difference between using the input eval function and switching to an integer like you did with the num apples sold. Does it make a difference either way?
Both certainly work. I like this, like the float and the int and stuff like that, because I can specify exactly what I want it to be. Like if I put eval here, then I cannot be guaranteed what type this ends up being, if that makes sense to you. Like if I put an int, I know this is going to be an integer. If I put eval, it could be an integer, it could be a float, it could even still be a string. Like if I typed in, whenever I say how many apples were sold, if I typed in Q, right? And if I put eval Q, then this is still going to be the string Q. And so that's going to cause me problems further whenever I try to do math on that, right? So that's why I prefer int. Now, if I can still run this, and if I type in Q here, the program will crash on me, right? If I type in Q, and that's because, it's saying it cannot take Q and convert it to an integer, and that's fine. But what I can do, and you'll learn this later on in the class, there's some more Python stuff you can put in here that instead of crashing with an error like that, you can detect when they have typed in the wrong thing, and you can warn the user, and then you can have them do it again and try again. So that's why I prefer specifying exactly what type I want it to be. But eval should certainly work in these as long as you type in what it should be. Type in 12 apples, $13 per apple, and that works. But if we type in this and do QW apples, well, QW is not defined, but and not always, but generally eval, whatever's in here needs to be Python code, not just a string. But I would just drop eval completely and use specifically what type you want it to be.
Okay, thank you.
I will stick around for about 5 more minutes. If anybody has any question that comes up, just go ahead and ask it right away, and I'll respond. If not, and you're done, feel free to drop off.
Yeah. Hello. Yeah, this is Ose. Um, what I want to ask is about the pseudocode. Um, the pseudocode, is it like the a flow chart that basically explains what the program is that we're writing? I'm still trying to understand that better.
Yep, that's a good question. No, it doesn't necessarily have to be a flow chart. And actually, flow chart probably makes it a little bit more difficult to understand. So let's say we have this same program right here. So that's the Python code, right? Now, pseudocode may look something like this. I'm going to use it as comments. It doesn't have to be comments. You can just type, text in the document.
Okay.
But so to do this, let's just talk it through in English. So I'm going to ask the user how many apples they sold. So the user will input number of apples sold, right? The next thing I do is ask the user how much per apple. So the user will input amount per apple, or cost per apple, however you want to label it.
Okay.
Then the next thing I do is I compute this mathematical value, right? So next thing I do is multiply number of apples times amount per apple. Then the next thing I do is I print out how much money that is. Print out result of the money computation. There, bam, that's my pseudocode. So the pseudocode is English-like, right? It's just normal language, how you would talk, and it describes what you've done. Now, we did it kind of backwards. I had the program and went to the pseudocode, but what you want to do is you want to make pseudocode and then make your program out of that. And the reason being is it's a lot easier to talk and think in pseudocode. It's a lot easier to think, well, I need the user to input how many apples they sold. Or for your assignment, I need the user to type in how many hours they worked this week, right? And so that's what we would put here. And so then after we have the pseudocode, imagine we didn't have any of the Python code. Now I can look at the pseudocode and be like, the user has to input the number of apples sold. Well, I know I have to use input and number, right? So that's going to be the user inputting the number of apples sold. And I need to save that, right?
Yep.
Just call it V. So that's how I'm implementing what this pseudocode is.
Okay.
I mean, I did not put in the pseudocode, all these integer conversions and float conversions and string conversions and stuff like that, because that's not important for pseudocode.
Okay.
But me saying that I need the user to input the number of apples sold, that's the first step I need to accomplish in order for my program to function correctly. This is the next step for my program to function, and so on and so forth. So that's what your pseudocode can look like, is basically sentence or fragments of sentences about the order of steps that you need to take in order to accomplish the program.
Okay. All right. Yeah, I get it. I get it.
Okay.
Yeah. So and then the pseudocode is going to be on the we're going to put it on the compiler or on that's on the Python compiler or when we're doing the Word document.
I'm fine with either one. Just keep in mind, if you put it in the Python file, you have to put these comments in front. That's what the hashtag means. The hashtag means it's a comment, and the compiler is going to ignore everything else.
Okay.
Because
Wow.
obviously, if you do this, Python has no idea what that means to do, right? So that's why you got to put it as a comment.
Okay.
It just means it's for somebody to read. The computer doesn't do anything with that. So if you want to put the pseudocode directly in this file, I'm fine with that. If you want to put it in the Word document, I'm fine with that. I'll find it either way.
Okay. All right. Thank you.
Hi, I'm Paige. I was wondering what else besides the pseudocode do you want in the test report, the Word document?
Let me bring up the assignment real fast just so I can read exactly what it says on there. I don't want to contradict what I put on the assignment. Okay, so a test case is, so let's take my example program that I've done here, right? Let me see if I can make a document real fast. Create new, blank file, file.txt. Where's that? All right, there we go. Imagine this is a Word document. I don't have Word installed on this laptop. So what could be test cases for this program? Well, we need to say what the input is, what the expected output is, what the actual output is, and did it pass or fail? And if you put this in a Word document, it kind of makes sense to make it in some kind of table or something like that. It makes it easy to look at. So for my program, I could put, say the input should be 10 and 3.14. The reason being is 10 is the first input, meaning how many apples sold. This is the second input. So yeah, I can make that bigger. This is the second input where I type in how much per apple. So without running it through the program, and I'm fine if you do this with a calculator, but what should be the result of my program if that is my input? If I programmed it right, that should be the output, right? Because we're just multiplying them together. Now, I want to run my program and put in those values and see what it gives me as an answer. So if I run my program, put in 10, 3.14. Now the actual output is this. Like I said, you can disregard all the extra decimal places. Copy. Oh, doesn't like copy. But the actual output is 31.40. And did that pass or fail? Obviously it passed, right? So that would be one complete test case. Let's say we want to do another test case. Let's say we want to be input is this time 3.14 and then 10. The expected output, it depends on if you know it would crash or not. As we've seen earlier, this would crash. And the reason being is because I'm taking that first number and converting it to an integer. but we can't take that and convert it to an integer. So actually, I'm expecting my output to crash. The actual output, well, let's see what it does. So let's run that, put in those values, 3.14, and it crashes. So the actual output was a crash. But that still passes because we expected it to crash. Okay, that's another test case. And you can keep doing these, 20 and 2.1, and what, you know, go ahead and fill out the rest of it. But the purpose of a test case is these two lines right here are the most two important lines. And the reason being, let's say I programmed this incorrectly, right? Let's say I did an addition instead of a multiplication, right? So let's go back to this test case. Obviously, I have an error in my program. It's not going to crash, but it's an error in my computation because this should be a multiplication. So in my test case, I put this is the input. This is what I'm expecting the output to be. Let's see what the output actually is. How many apples sold? 10, 3.14. And it says I made $13.14. But obviously, that is not correct, right? 13.14. So in this case, it failed. But generally, if you ever have a fail here, it should be a warning sign to you that somewhere in your program, you're doing something wrong, right? It should be a sign that you need to fix your program basically before you turn it in. Because if I would come behind and grade this, you would get a good amount of credit, but you would get points taken off because you did the wrong computation, right? And the test case is to help you catch that. That's why when you do the expected output, make sure you do that calculation by hand, or you do it with a calculator. That's fine. Don't just run your program. For example, let's say I just run my program and this is what came out, 1314. Oh, that must be the expected output as well. Obviously, that's wrong. That's incorrect. And that'll get you a lot of points taken off because this is clearly wrong. That should not be the output. The output should be 31.40. And since this is what your program produced, there's something wrong with your program and you need to go back and fix it. That's the point of a test case. And that's kind of what your test case should look like. Like I say, if it's in a Word document, it'd look real nice if you put it in some kind of table. But that's the contents that should be in it.
Got it. Thank you.
All right, if there's nothing else, I'm going to go ahead and shut the session down. Like I said at the beginning, I do have this recorded, and I will get it uploaded and a link sent out to everyone so you can review it later if you need to go back and look at anything. So one more call for any questions.
Thank you very much. The class has been very helpful.
Okay, you're welcome. And if you need anything at all, please feel free to email me and I'll get back to you as soon as I can. All right, everyone, have a good night.
Thank you too.
Good night, Prof.